Centrifugal pumps are a dynamic pump that operate on the principle of centrifugal force. Centrifugal force is a force that tends to move objects away from the center in a system undergoing circular motion. The casing on a centrifugal pump is designed to contain the fluid, form a volute, and hold external and internal parts together. Most are two pieces and bolted together with a gasket in between. A radial split casing is split perpendicular to the pump shaft, and an axial split casing is split parallel to the shaft. The volute is a gradually widening cavity inside the casing, which serves as a discharge for the pump. The inlet to the valve is commonly referred to as the suction eye. Fluid enters from the center and is spun outward to the volute by the impeller. In order to operate correctly, the inlet line must be primed. The impeller is a set of blades that rotate around the drive shaft, which spins and transfers the fluid from the center to the discharge. The driver can be either an electric motor or steam turbine. The shaft is what connects the driver to the impeller. The stuffing box and packing gland hold the packing against the shaft and casing. This allows shaft movement through the casing while at the same time preventing leakage from the pump. If a pump was said to be horizontal, it means that the shaft is horizontal to the ground. Horizontal seems to be the most common type in industry. However, vertical pumps are more compact, winterize better, and tend to have lower installation costs. The simplest type of centrifugal pump is a single-stage pump. A single stage has only one impeller. In a multi-stage pump, the fluid enters the suction eye of the first stage impeller and is sent into the suction of the second stage impeller. The fluid flow and pressure will continue to increase at each stage until it reaches the discharge. Most centrifugal pumps have just a single inlet. Some applications require a higher volume of pumping. In these circumstances, a pump with more than one suction can be used. Impellers come in three basic designs. An open impeller has vanes that are only connected to the shaft. It is self-cleaning but has very little structural support. A semi-open impeller has the vanes connected horizontally to a plate on one side for more support. The vanes of a closed impeller are closed in between two plates for maximum support. This is the strongest, most common, and most efficient design, but it is limited to use with clear liquids only. Pressure head is a convenient term used in pumping to describe the pressure required to force liquid into a pump. In order to calculate the system, you will need to know the static head on both the suction and the discharge side of the pump. In addition to static head, there are two more heads you will need to know to complete the calculation. The static head of a pump is the maximum height or pressure it can deliver. Static head is due to gravitational force on a column of fluid. The head caused by resistance in the piping, fittings, and valves is called friction head. Surface pressure head is caused by any pressure that might be acting on the liquid in the tanks, including atmospheric pressure. The total suction head consists of 3 separate heads. The total suction head equals suction static head plus suction surface pressure head minus suction friction head. The total discharge head is also made up of 3 separate heads. Discharge head equals discharge static head plus discharge surface pressure head plus discharge friction head. To calculate the total system head, subtract the total suction head from the total discharge head. When cavities or air pockets form in the fluid being pumped, it is called cavitation. Cavitation occurs on the suction side of the pump. There are 5 basic causes for this: vaporization, air ingestion, internal recirculation, flow turbulence, and the vein passing syndrome. The effects of cavitation are: the cavities or bubbles will collapse when they pass into higher regions of pressure, causing noise, vibration, and damage to many of the components. You will also experience a loss in capacity. The pump can no longer build the same pressure, and the pump's efficiency drops. Rapid swings in the discharge pressure are one way to recognize cavitation. Another way to recognize cavitation is by sound. Cavitating pumps resemble the noise of steel ball bearings being introduced into the pump. A cavitating pump must be resolved quickly in order to avoid severe damage. Some advantages to centrifugal pumps are cheaper costs and less maintenance and space are required. Another advantage is that they will work with a constant head pressure over a wide capacity range. The final advantage is the variety of drivers available to use. Centrifugal pumps do have some disadvantages too. They are not self-priming and respond poorly to viscous materials and suction pressures. Thank you for viewing this procedure. If you need to test or have any comments about any aspect of this procedure, please click the appropriate link below.